Technically, in order for a function to have an inverse, it has to be one-to-one. But if we think of inverses as functions that undo each other, wouldn't we expect x squared and square root of x to be inverses? The domain of a function has the same range as its inverse, and the range of a function has the same domain as its inverse. So in order for these two functions to be inverses, the domain has to equal the range, and the domain has to equal the range. Ooh, here's our problem. But there's a way around it. If we restrict this domain to 0 to infinity, it cuts off that part of the graph, but now we have two functions that are inverses of each other. All right, why would we ever do that? We're going to do that later on in trig a lot. So let's practice it just with two more familiar functions before we get into the trig functions later in the semester. One thing I want you to realize, I told you the domain here is going to equal the range here if they're inverses, and the range here will equal the domain here if they're inverses. So it may help you to think about transformations. Remember, if I add something to the end of this function, it'll move the graph up, which will change my range. Same thing here, if I add something to the end of the function, it'll move the graph up, which will change my range. And if I add something under my square root or as part of my parentheses, it will change my domain. Okay, let's do some examples. It's not quite as difficult as it seems. Determine the inverse of the following functions. So y equals square root of 2x plus 8 on the domain -4 to infinity. Let's first figure out what the inverse would be. So remember, that means switch your x and y's and then solve for y. If you want to write it in inverse notation, this is my inverse. Okay, but we have to talk about the restricted domain here. So the range of the original is going to be the domain of my new function. What is the range of this original function? Well, it's a square root function. There's nothing added to the end, so its range is just 0 to infinity. So that means the domain of my inverse is also 0 to infinity. Let's do another example. Y equals the square root of 5 minus x plus 6 on the domain -infinity to 5. All right, let's find our inverse function first. Switch your x's and y's. Solve for y. Okay, before we say this is our final answer, we have to specify what the domain is. So the range of the original equation is the domain. A normal square root graph starts at 0, but this has a plus 6, so I'm moving the square root up 6. So my range, instead of being 0 to infinity, it's now 6 to infinity. Whatever is added or subtracted here will be this number. The range of my original function is the domain of my inverse, and that's it. Let's do one example where we start with a squared function, and I'll show you it's the exact same idea still. Determine the inverse of f of x equals x plus 2 all squared plus 9 on the domain -2 to infinity. So first, let's figure out what the inverse function is. Switch your x and y values and then solve for y. The range of the original equation is the same as the domain of the inverse. The range on an original square root graph is 0 to infinity, but I have this plus 9 added, which moves my u up 9. That means my range is now 9 to infinity. So my domain on the inverse graph is also going to be 9 to infinity. Whatever is added to the end of your squared or your square root, that number will affect the range of the original, which means it will affect the domain of the inverse.